All right, so let's go on with this example too. All right, so we have some interesting questions looking up here. So we have to simplify the following. A says 5 to the power of 4 over 3 to the power of 2 times 2 to the power of 3. And then we have some interesting looking questions in B and C as well. So let's undo them together now. So let's take the first one. So we have the first one which says A, we have 5 to the power of 4 over 3 raised to the power of 2 times 2 to the power of 3. So if you look at this question, we don't have any similar number. We don't have the same number anywhere here. So we are not going to be applying the laws of indices. All we just have to do is simplify, right, as well as we can. So we can remember that 5 to the power of 4 says 5 times 5 times 5 times 5, okay, over, now what do we have? We have 3 raised to the power of 2 is 3 times 3, and we have 2 raised to the power of 3 is 2 times 2 times 2, okay, times 2 is the last one. Okay, so now we have 5 times 5 times 5 times 5. 5 times 5 is 25, times 5 is 125, times another 5 is 625. Okay, so that's settled. 3 times 3 is a 9, and 2 times 2 times 2 is 8. So we have that to be 625 over 72. So next time you have numbers that, they are not the same and you have to simplify in indices, all you just need to do is basically express them, do the normal multiplication that we know and we are familiar with, basically. Okay, so let's take the second question. So we have 8m squared n cubed over 5x squared yz times 15x yz cubed over 16mn squared. So what we do from here is that we simplify in place, right? So we try and simplify. From here we can say that 8 here is 1, 8 and 16 is 2, 5 here is 1, 5 and 15 is 3. So let's try and bring that together and see what we have. So from there we have m squared n cubed over x squared yz multiplied by, we have 3xyz cubed over 2mn squared. Okay, so we can say that your y cuts a y, and x here 1, x here is x. Okay, we have m here 1, m here is left with an m. Okay, n squared here 1, n squared here will remain an n, because 3 minus 2 is 1 there over there. And we also have your z here is 1, and z here is z squared. Okay, hopefully that's not too messy. Let's see what we have as our answer. So over here we have m and n, and over here we have an x multiplied by, so we have 3 and z squared here, 3z squared, and we have 2 left here. So putting it all together, we are going to have 3mn z squared over 2x. So I believe that's the answer to the second question that we see over there. So let's take this third one that we see here. 15b squared over 40c times 27c squared over 81d squared d cubed divided by abc over 8d cubed. So first of all, when we have a division sign, all we have to do in fractions is we turn this upside down and change this to the multiplication sign. So when I'm writing the question, I'll turn it upside down and I've changed the this to a multiplication sign. So let me do that in the next page. So we're going to have 15b squared over 40c multiplied by 27c squared over 81d cubed times we have 8d cubed, so that's 8d cubed over ABC. So that's A, B, and C. Okay, so let's go on from there. So all right, so we know that your D cubed should take away a D cubed here. C here 1, C here is left with a C, and C we take away the C again. Okay, 81 and this. Okay, 8 here 1, 8 and 40 is a 5. Okay, 5 here 1, 5 and 15 is a 3. 3 here 1, 3 and 21, 81 is 27, and 27 cuts 27. Okay, so let's see if we got everything from there. So from there we are left with B squared. Okay, nothing is left. Multiply by what do we have here? Looks like everything here is gone. So here we are left with okay, 1 over AB. Okay, so B takes one of the B, and our answer we are left with at the end of the day is B over A. Okay, so in case you have a very messy work or you really don't like doing everything at once, you can basically break everything in multiple stages. So you can do some, then come back to cut down again as well. It's just basically how it works. So you don't have too much a messy work so that you can see everything that is going on. But of course, if you are very good at what you are doing, then basically just cut it all up again. So in this basic example, this second example we just did, so the intention is more or less to show you that although the topic is indices, when we don't have the same base, when we don't have the same number or the same base, right, like 5, 3, and 2, we can call them base. Yeah, all you just have to do is not start trying to force the law of indices where it doesn't apply. All you just have to do is work the same normal algebra, right? Cut the numbers where it can cut, divide the number where it can cut, and then do your thing. Basically, that's just how that works. Okay, so from the next video we'll go on with the laws of indices.